Okay, basically my group, we're looking at bio-optics and ocean color remote sensing for Baltic Sea management. In my group, Therese is mostly working on BEAM, and we also have collaboration with Agnieszka Andersson. And I also have to acknowledge some people from our Nordic network, Krista Alikas from Estonia and Petra Philipsson from Brockman Geomatic AB, Sweden. So basically the products that we can derive from ocean color remote sensing that are useful for management are colored dissolved organic matter. That's basically the chromophoric part of DOC. And then suspended particulate matter, SPM, which is also termed total suspended matter. And then of course chlorophyll. We can also derive additional products from reflectance, and this is KD490, the diffuse attenuation coefficient, and Z90, which is the depth at which 10% of the light level remains of the surface level. And these can be used for primary production models. So these can be used as indicators for water quality. So color dissolved organic matter and suspended particulate matter are indicators for terrestrial runoff and also for extreme storm events. But SPM falls out within about 15 kilometers from the coast, at least for the northern Baltic we have shown that, whereas CDOM remains quite high also in the open Baltic Sea. And chlorophyll A can be used to derive phenology patterns from space. For example, if you want to look if there was actually a later onset of autumn blooms, and you can do this with very high spatial and temporal resolution. What we have done mostly in BEAM was that we collaborated with Agnieszka Andersson, and we have been looking at the difference in optical properties in the Bosnian Sea compared to the Åland Sea, area 2-4, and the Baltic proper. I just show a few results from this. Basically, we can find that the colored part of the dissolved organic carbon is much higher in the Gulf of Bosnia. These are the yellow points. So the chromophoric part of DOC is much higher in the Gulf of Bosnia, and we found that for the Åland Sea and for the Baltic proper we could actually pull the data together, but we have different relationships for the different basins. Then we can also look at the slope factor for CDOM. It's basically the way when you measure CDOM in a spectrophotometer, it has a certain slope of attenuation, absorption, and this is also quite different in those different areas. And also we can look at the relationship between Secchi depth and CDOM, which is also different for those areas. But we will work more on this. We have submitted a manuscript for this special issue, and I'm beyond hope that we will get that in there, of course. Then we have worked a lot on validation, and I don't want to go too much into the details, but this is very important because to make sure that the data is reliable. And we basically use two different ways of validating. One is to compare to matchups within ±2 hours of the satellite overpass, and we can then derive uncertainty estimates of the products. Or we can also compare to the coastal monitoring system where we compare within ±3 days, but this is not proper sea-truthing, but it is a comparison of methods. We got very nice results for that. Therese has submitted a manuscript about that, and we found that there was really no significant difference in those methods, in the ship measurements and the remote sensing measurements. So then algorithm development is important because we need to derive Baltic Sea specific algorithms. And if we use the normal reflectance ratio that we use in case 1 in clear ocean waters, we retrieve only an R² of to 8 in the Baltic and in optically complex water. So we know we can't use that. So we found if we use different band ratios at 560 and 709 nanometers, we get much better retrieval, and also for 90 to 709, sorry. And then we have developed a combined band ratio algorithm, because it depends both on how much CDOM there is and how much SPM, which of these algorithms work better. But basically we have... Okay. We have derived that algorithm for the Baltic, and then we have had very good retrieval, only 17% error. We can derive the diffuse attenuation coefficient for the whole Baltic Sea basin, and also set 90, where we have only 10% of the light left. And we have also a new Secchi depth algorithm that is based on beam transmission and beam attenuation and diffuse attenuation. It's an empirical algorithm. Then this is also applied to an operational monitoring system, and we can derive water quality status. Here's an example from the latest system that was produced by Petra Philipson. So this is actually operational and can be accessed. Then the papers, we have one accepted on management, basically how to use remote sensing in management. This was already published in May this year online, but will come out early next year on paper. Then we have quite a number of submitted manuscripts just on these things I've been talking about. And we are planning to write this special issue on DOC and CDOM. And then we have various others on the go that are also relevant for management. Also deriving the Secchi depth algorithm will be another manuscript. Yeah, thank you very much.